WebRTC, or Web Real-Time Communication, is a technology that exists in most modern browsers that allows users to communicate with one another in real time right from within their browsers without actually having to use a server. So if you'd actually like to learn how to use this really cool technology to build a video chat application, you've come to the right video. So before we actually build this video chat application together, let's first talk a little bit about what WebRTC actually is. So WebRTC, as I mentioned, pretty much stands for Web Real-Time Communication, and it's a technology that exists in most modern browsers that allows users to kind of communicate with one another all in real time right from within their browser. And what's kind of really neat about this is that the actual communication that's happening from one peer to the other peer all happens without a server. Now, that's not to say that there are no servers involved in Web Real-Time Communication. For example, in the video that in the project that we're going to be sort of working on together right now, this sort of video chat application, there in fact will be a server. We're going to actually be using an Express and Socket.io server on our backend, but that server is sort of just responsible for actually facilitating the connection between the two peers. But once the two peers actually have a proper connection with one another, the server is no longer used. They are not communicating with each other directly without the actual use of a server. So with that little introduction out of the way, let's actually start writing some code. So the first thing we're going to do is head on over to our terminal. We're going to go ahead and make a new folder. We're going to call this video chat. We're then going to cd into this video chat folder. And then what I'm going to do is I'm going to say yarn init-y. This will basically create a new package.json. We're going to use the -y flag to basically accept all the default answers to all the questions that you typically get asked when you're creating a new package.json. Then let's go ahead and say git init. We're going to turn this into a Git repository. And then finally, what we're going to do is we're going to go ahead and create a client folder that we are going to be bootstrapping a React application into. So in other words, we're going to be using the create React app CLI to go ahead and build a new React application that's going to serve as the client-side part of this application. So what we're going to do is we're going to say npx create React app client, and then what this is going to do is directly inside the root of our application, there's going to be a folder called client that will effectively be the sort of client-side part of our application that will just be a React application bootstrapped using create React app. So this will of course take a minute. So I'll be back once this is done. Okay, so now that that's done, let's go ahead and open up another terminal. We're going to go ahead and navigate back to our projects. We're going to say cd projects, video chat. But in the second terminal, we're actually going to go ahead and navigate over to the actual client folder. So now we effectively have two terminals open pointing to the same project. The first one is going to be in the root of the project, just at a video chat, no other folders. This will basically serve as the terminal that's responsible for all of our backend code. And then in this terminal here will be pointing to the actual client folder. This is going to be responsible for all of our actual client side or the actual React application part of this application. So for dependencies in the actual root of the application, we're going to need to install Express as well as Socket.io. So we're going to go ahead and say yarn add Express and Socket.io. For the client application, what we're going to want to do is we're going to want to install Socket.io client, UID, and React Router DOM. So Socket.io client, of course, is because we're going to be having the sort of Socket.io on the server. So we need to have our client application be able to communicate with our server. So we have to install Socket.io client on the client. We're not going to be installing UID. This is going to be for the sake of creating rooms, which we're going to talk about in just a moment. And then finally, we're going to be installing React Router DOM just so that we can actually navigate between the different screens that are going to exist within our client-side application. So let's go ahead and hit enter and install these dependencies. Okay, so now that that's done, let's go ahead back to our server terminal, and let's go ahead and create a file called gitignore, and then we're also going to say touch server.js. Then finally, we're going to open up our editor of choice. In my case, that's going to be VS Code. Of course, you can use whatever you want. And then the first order of business is to simply go to this gitignore and then just populate it with our gitignore right over here. So I'm going to leave a gist to this gitignore that I'm using down in the description box below, so you can just go ahead and grab the contents and then paste that in directly to your gitignore. Okay, so for now, the first thing that we're going to want to do is actually start building up our server-side code. So basically, the whole point, again, as I mentioned, the whole point of our server-side code, right? Because again, WebRTC in reality, just for the actual sake of communicating one peer with another peer, they don't in fact require a server. The whole purpose of our server here is to actually allow the sort of connection to happen between the different peers. So the kind of flow that our application is going to have effectively is just going to be a URL in the sort of client-side application. In our case, it'll be like localhost 3000/room/some random ID. When two people find themselves within the same URL at the same time, these two people are automatically going to go into an actual conversation with each other, an actual video chat application, and that's kind of going to happen automatically. So the way this would work is, let's say user A actually creates a room. So they're going to have like a button that they can press that says create room. When they actually do that, they're going to then get navigated over to localhost 3000/room/the room ID that they've just created. At this point, they're the only person here, so all they're really going to see is just going to be their own video, but they're not actually going to be in any kind of conversation just yet. Finally, when they actually take this URL and then share it with somebody who they want to have a chat with, that other person will then click on that link, join the same room. At this point, the second person that's joining, effectively user B that's now joining, will actually go ahead and initiate a phone call back to user A. And so now what's going to end up happening is the second user that's joining, his peer that we're going to be creating for him, will go ahead and create what's known as an offer. So what we now need to do is actually go ahead and take this offer, send it down to our Socket.io server. The Socket.io server will then go ahead and send this offer up to user A, right? Because again, the idea is we actually have to sort of create this handshake. We have to actually create the connection between the two peers. Without this connection, they don't actually have data flowing between one another, and then there's not going to be any sort of WebRTC goodness happening. So to kind of facilitate this actual handshake, what we need to do is we need to take this offer that's going to be created by user B, send it down to the Socket.io server, which will then send it back out to user A. And then in return, user A will go ahead and formulate what's known as an answer in response to this offer, take this answer, send it back down to the server, and then the server is actually going to go ahead and send it back out to user B. Once this sort of round trip process is done, and once they've sort of sent each other an offer and an answer, now they've actually created a proper handshake. Now they can start communicating with one to another. That's what our server-side code is going to be doing right now. I'm going to write this code and explain to you what I've done line by line. So let's do that right now. Okay, so let's actually take a look at what we have so far. First thing I've done is I've actually imported the express module by simply saying const express is equal to require express. I'm then importing HTTP by simply saying require HTTP. Now there's no need to install HTTP, it's a built-in node module. We're then going to go ahead and create an app object. This is basically going to be our express app. We do this by calling the express function. Finally, over here, we're going to say const server is equal to http.createServer, passing in our express app, which we've just created up over here on line 3. We're then going to go ahead and import Socket.io, and we're going to create this variable called socket by importing Socket.io. Then finally, we go ahead and create this instance of IO by calling socket, passing in a newly created server. So effectively, we've taken our app, our express app, we've attached it to our HTTP server, which we then take and attach to our actual Socket.io instance. And then the last thing we now need to do right before we can actually start writing code, but just as far as boilerplate is concerned, is we just need to go ahead and tell our server to listen on port 8000, and then we're going to have a simple callback saying that the server is in fact running on port 8000. Okay, so as I've mentioned, the basic idea is going to be that a person will be able to sort of create a room, right? That's going to be defined by some sort of arbitrary URL or by some sort of arbitrary ID that exists within the URL. And then another person that will then go ahead and join the room will then effectively be in the room together with this first person. And now they're going to be in a sort of video chat application with one another. So the way that that's going to work is with exactly this code that I have on screen right over here. So what we've effectively done is we're creating this rooms collection here, just a basic object, right? And then we have this event that we can listen at on this IO. We're basically saying IO did on a connection. When a person finally actually connects to our Socket.io server, this connection event is going to fire. Socket.io will then go ahead and generate the socket object for this individual person. And then what we're going to do is we're going to go ahead and attach an event listener on this particular socket set that's going to be called join room. So this join room event will then get fired off from within the client-side code. Once we actually get to the client-side code, you'll see how this gets fired off. But basically, when it does in fact get fired off, what's going to happen is we're going to be pulling the room ID out of the URL and then sending it down to the server. Now what the server is going to do is going to have a basic if check. If this room's a room ID, if this room already exists in our rooms collection, then basically that means that at that particular key in the rooms collection or in the rooms object, that means we already have an array of socket IDs, right? So in other words, we can simply say rooms of room ID that push, take the socket.id. So basically every single time that you create a new socket with Socket.io, Socket.io will automatically put a generated ID onto the individual socket to kind of identify this socket. So all we're going to do is we're going to say in this room, at rooms of room ID, in other words, in this room we already have a user with a socket ID. Now the new person that just joined, take their socket ID and push it as well into that same array. This all assumes that this room already exists. However, if this room doesn't yet exist, then what we're going to go ahead and do is say rooms of room ID is equal to an array with the first socket ID. In other words, the first person that just kind of created the room, they're the first person here. We're just going to go ahead and take their ID and put it into a newly created array at this particular room ID inside of the rooms object. Finally, what we're then going to do is we're going to go ahead and say const other user. We're going to go ahead and try to find the other user. So basically now what we want to do is we want to check to see, is there already somebody else within this room? In other words, am I user A that's currently joining or am I user B that's currently joining, right? So the way that we're going to do this is we're pretty much going to go to the room of the room ID, right? In other words, we're going to go to this particular room ID inside of the rooms collection, and then we're going to go to that array and perform a simple find. And the way that this find is going to work is we're pretty much going to try to see, is there an ID inside of this array that is not my own, right? So the assumption here is that since at any given point in time, there's only going to sort of be 2 people within a room, because we're only just having a bunch of one-on-one conversations happening. So at any given point in time, only 2 IDs will exist within one array. And so then the basic idea is that so long as I find an ID that is not equal to my own, that means that somebody else is here with me. So I want to actually go ahead and get that ID of the other person, because A, I'm going to know that somebody else is here, and B, I need that ID to kind of know who I'm actually trying to call by sending my offer to them. And so what we're going to do here is we're going to have a basic if check. If other user does in fact exist, that means somebody else is actually there. Then what we're going to do is we're going to emit an event back to ourselves with the event called other user, which basically telling ourselves that yes, there is another user here, and this is that user's ID. And then to the other user, the one that's already here, we're going to be telling them, by the way, somebody else has joined, and this is their user, or this is their user ID. So basically what's happening now is when user B joins the room where user A already is, what's going to end up happening is user B will kind of get notified that user A exists, and then user B will get user A's ID. And on the flip side of that, user A, who's now been sitting in the room waiting for somebody else to join, will get notified that somebody did in fact join, and will also be notified of what that other person's user ID actually is. So far, all this code pretty much just handles the logic of actually joining the room. Now we need to start writing the logic of what it takes to actually facilitate the handshake between the 2 peers. In other words, the actual process of sending an offer, receiving an offer, and so on and so forth. So let's actually write that code now. All right, so what we've just done basically is I've created this event called offer. We're basically saying socket.offer. When the offer event gets fired, it's going to be accepting this payload as an argument, this payload object as an argument. And then what we're going to do is we're pretty much going to say io.to. We're going to pretty much be calling on our io object, and we're going to say go ahead and send that an event to payload.target, right? So in other words, the person who I'm trying to call. So in other words, I'm user B. I'm trying to call user A, so I'm going to be sending an event to user A's ID. So this target over here will represent the socket ID of the person who I'm trying to send an event to. I'm going to be emitting the event called offer with the payload. Now this payload will pretty much include 2 very important things. The first one is who am I as the caller, as well as the actual sort of offer objects. In other words, when you're actually going to create an offer, there's some sort of arbitrary data. Well, it's not really that arbitrary. It's actually quite meaningful to WebRTC, but us as developers don't need to really worry about too much about what this data actually is. We just need to know that given this data, we have to actually go ahead and send it off to the other user. So this data now will be what we're going to call the offer. So effectively, we're going to be taking the offer and then sending it to the other user. So again, payload will include actually who am I, the caller, my ID, as well as the offer that I'm now trying to send to the other user. So now what we've done is we've pretty much gone ahead and created another event called answer. So the answer event will pretty much happen when, say, user A is calling user B, and now user B is actually answering. So now we're going to be basically sending back to user A an event saying, by the way, you're receiving an answer, right? And so the basic idea is like this. I have now received the offer. I'm now going to go ahead and formulate my answer. So just like the offer is some sort of bit of data that needs to get sent to the other peer, the answer is another bit of data that has to get sent back to the original peer that has been trying to call me. So what's going to happen is we're going to be listening out for this answer event, and then for this answer event, we're pretty much going to be getting this payload argument, this payload object. It's going to include the target of who we're trying to send the event to, and then the actual payload, which is of course going to include the actual answer data that we need to actually send back to the calling peer. Now finally, the last thing that needs to happen in our server-side code is we're pretty much going to have this event called ICE candidate. So very briefly, without kind of getting into too many details about what an ICE candidate is, when the 2 peers are trying to sort of have a connection between each other, of course, in a real life scenario, there's going to be firewalls, and we're also going to have to figure out like which IP address to try to connect to and sort of all that sort of low-level networking stuff. And so there's a concept known as ICE servers, which basically is either a stun server or a turn server. And these are basically responsible for trying to create what's known as an ICE candidate. An ICE candidate, pretty much at the sort of most basic definition, is just a way for sort of 2 peers to kind of agree upon a certain proper connection that they can both agree on that's going to work for them. And so each sort of peer will kind of come up with a bunch of different candidates until they've exhausted all their options, until they finally reach a sort of mutual agreement about which candidate kind of makes sense for them. And so then what's going to happen is this event will basically get used by sort of both peers, because basically peer A will come up with the candidate, send that to peer B will kind of come up with its own candidate, send that back to peer A. At some point in time, they're pretty much going to come to some kind of conclusion about which candidate kind of makes sense for them, and then they're going to pretty much finish their handshake and have a proper connection. And that pretty much concludes all the server-side code. We can now go ahead and jump into the actual client-side code. All right, so one of the first things we're going to want to do in the client side now is we're going to want to go to our source folder, and inside of that we're going to want to create a new folder called routes. Now within routes, we pretty much want to create two files. The first one is going to be called room.js, and then the second one is going to be called createroom.js. All right, so let's first take a look at what createroom.js needs to do. Okay, so in createroom, as you can see here, what I've pretty much done is I'm importing React, I'm importing the UID library. So once again, this is going to be used to sort of generate the unique ID for the individual room. I am then creating a component called createroom, which on line 15, I'm simply going to export. The component will define a function called create. Within create, I'm pretty much creating an ID by calling the UID function. And then I'm just going to go ahead and say props.history.push, go ahead and navigate me over to the /room/ID, right? So in other words, in the actual room, the sort of localhost 3000/room/some IDs where the actual conversation is going to basically be happening. So any two people that find themselves under /room/some ID, that ID is going to represent the actual room that they are both tied to, and that therefore if they're both within that same room at the same time, they can actually have a conversation with each other. And so basically what's going to happen is if any one person wants to kind of go ahead and create a new room that they can then take that URL to share to somebody else, the first screen that they're going to want to be met with is going to be this one. So this one will be at like localhost 3000, just at the base URL. They'll be met with the button that pretty much says create room. When they click on that button, they're going to go ahead and call this function create an ID, and then they're going to navigate over to props.history.push, go to /room/ID, and now they're going to be within that sort of room where the actual chat is going to happen. They're going to take the URL, send it to some friend who they want to actually have a chat with. When that person actually joins that same URL, they're now both within the same room, and then the sort of signaling process of actual WebRTC handshaking will start happening between their peers, and within a few seconds they'll be in an actual video chat application if it all goes well. So this now brings us to the actual room file where the actual video chat application logic is going to actually exist. Okay, so here's what we have so far within our room.js file. As you can see, I'm importing React, useRef, and useEffect from the React library. I'm then importing IO from the socket.io client. So basically the client-side version of socket.io. I'm going to go ahead and import IO. I'm then creating a component called room. And then I'm just kind of setting up a whole bunch of refs that we're going to be using. So we've got the user video ref, the partner video ref, the peer ref, the socket ref, other user, and user stream. All these refs are going to get used. And as we start to kind of build up the code for this particular component, you're going to actually see how each one of these refs get used. So far, what we can already see is how the user video ref and the partner video ref are getting used, because when we come down to our return statement, where we're actually going to go ahead and build up our JSX, you'll notice that we are returning two video tags, and sort of one video tag is referencing our user video ref, and then the other video tag is referencing our partner video tag or video ref. And the basic idea is we kind of want to have one video tag to display our own video, and then one other video tag to display our partner video. And we're going to basically be using the refs to kind of attach the stream, which we're soon going to see how this is actually done, to the individual ref, so that we can actually start displaying our own video as well as our partner's video on the screen. Okay, so now what we're doing is we're pretty much defining this use effect over here. And as you can see by the fact that we have the empty array here for the dependency array, we're pretty much treating this use effect as a basic did mount. And then what we're doing is we're pretty much going to go ahead and ask the browser to grant us access to the user's video as well as their audio. So when the browser is going to go ahead and ask the user to kind of give us access, when the user is going to actually hit allow, then this promise is going to go ahead and resolve. And then when it resolves, we're actually going to get this stream object that's going to actually include both the audio and the video, because that's what we actually went ahead and asked for. Then what we're going to do is we're going to go ahead and take the stream, and then we're going to attach it to the source object of our user video ref. That's going to allow us to actually go ahead and display the actual video of ourselves in the actual video tag in the browser. And then finally, what we're also doing is we're just taking this sort of stream and attaching it to this user stream ref over here, kind of just storing it for later use because we're going to need it in a couple of minutes. Okay, so now what we're doing is we're pretty much going to go ahead and connect to our socket.io server. And then immediately after that's done, we're going to go ahead and emit an event back down to the server saying that we're trying to join the room. So remember, if we come back to the server, we have the event that the server is listening out on. It's called join room. So this is where we're going to go ahead and actually emit that event. And then we're pretty much going to be passing down the room ID by pulling it out of the URL by saying props.match.params.room ID. That's the sort of React Router DOM way of actually pulling out parameters from the URL. We're going to go ahead and grab the room ID out and then go ahead and send it down to the server so that the server can go ahead and put us in to a specific room within the sort of rooms object that we kind of have created within the server. So now what we have is we pretty much have this other user event that the server is going to either fire back to us or it won't, depending if somebody else is already here, right? So in other words, in this case, let's imagine that user A already is in this room, and now user B is the one that's joining. So in the case when user B is the one that's joining, this other user event is going to in fact fire, and what we're going to get as user ID is going to be user A's user ID. So user B is the one that's currently joining, user A already is in the room, so when user B joins, the server will go ahead and send them back a message saying, by the way, this is the other user, and this is their ID. And then immediately what we're going to go ahead and do is we're going to go ahead and call this function called call user, which of course doesn't exist yet. We're going to fill that function in very soon. And then what it does is it actually takes this user ID and passes it down to the call user function. Then also very simply what we're doing is we're taking this user ID that we just got and we're storing it in the other user ref because we're going to need it for safekeeping for a little bit later. And we're going to see soon when we do in fact need that. And then also what's going to happen is the user joined event will then get fired for the person that's already been in the room, right? So the scenario here again was that user B is the one that's currently joining, user A is the one that's already been in the room. So when user B joins, they're going to get notified about user A, and then user A is going to get notified about user B. So other user is going to kind of get sent off to user B, the one that's currently joining, and then user A, the one who's currently already been in the room, is the one that's going to get notified about the person that's just joined through the user joined event. And then they're also going to sort of receive the user ID from this event, which they're also going to put into the other user ref, which they're going to use for safekeeping for a little bit later. And once again, we're going to see very soon how this is in fact going to get used. Okay, so 3 more events that we're going to be listening out for within our socket IO connection here inside of the use effect. So the first one is going to be the offer, right? So in other words, what happens when we are in fact receiving an offer? So that's going to go ahead and call the handle receive call function, which of course doesn't exist yet. We're going to fill that in very soon. Then what happens when we're going to be getting an answer, right? So in other words, we received an offer, and then we're sending an answer back. So now the person who was the one that made the original call, they're now getting an answer in return. So they have to be able to listen out for that answer. And that's when this event is going to get fired. It's going to call the handle answer function, which I'm now noticing is spelled incorrectly. And then finally, we have the ICE candidate event. So this is sort of, again, where the each peer will kind of be exchanging ICE candidates with each other. So they're both going to be listening for this ICE candidate event. And then when this event gets fired, we're going to go ahead and call the handle ICE candidate message function. Well, for now, let's go ahead and see what does this call user function actually look like. Okay, so as you can see, all the call user function is really doing is it's pretty much accepting the user ID as an argument, which we're passing in right over here. We're then going to go ahead and say peerref.current. So we do in fact have a ref that we're calling peerref. That's going to pretty much be equal to whatever this create peer function returns. So obviously this function doesn't exist yet. We're going to have to go build it up really soon. But suffice it to say, this is the one that's going to actually build an actual WebRTC peer object. And then we're going to return that from within the function, which we're then going to store inside the peerref ref. And then the next thing that's going to do is it's pretty much going to go to our stream, right? So remember, we actually took the stream and we stored it inside of this uStream ref for safekeeping for using it later. This is one such instance where we're going to be using that actual ref. And then what we're doing is we're pretty much going to go ahead and call the getTracks method that exists on the stream. That's going to go ahead and return an array of all the tracks that we have on this particular stream. In this case, it's going to be an array of 2 because we've got 1 track for the video, 1 track for the audio. We're going to go ahead and for each over that. And then we're going to call the add track method that exists on our peer object. And then the add track method will basically is a function that will pretty much accept 2 arguments. The first one is going to be the individual track as well as the overall stream that this track is included as part of. Right? And the reason why we're doing this is we're pretty much taking our stream and attaching it to our peer, because once we actually have the sort of peers both connected to one another, we want our peer to actually be able to send. We want it to have the capability of sending our stream to the person who we're trying to have a video chat with. So in order to do that, we have to sort of give our peer sort of access to our individual stream. That's what you can kind of think of this as. Now that we've actually seen the create peer function, let's actually go ahead and build that up and see what that entails. All right, so as you can see, we've got the create peer function right over here. It's accepting this user ID as an argument. Again, this user ID represents the person who we're trying to call. So we are the ones who are currently making the initial call. We're the ones who are initiating the call. So the user ID represents the person who's going to be receiving our offer. And then all we're doing is we're pretty much creating this peer object by calling the RTCP or the RTC peer connection constructor. And they're pretty much the only configuration object that we're passing into it is going to be these ICE servers. So we're pretty much going to be, the ICE servers is just an array of objects. We're going to be setting up 1 for the stun, 1 for the turn, What these actually do, I'm not going to get into too many details. I will leave some MDN documentation down in the description box below if you want to kind of read up about this in more detail. But the basic idea is this will allow us to sort of get through most of the networking hurdles that might exist in real life applications about bypassing different firewalls and different security mechanisms that most people might have within their computers. Using this sort of stun and or turn servers will allow us to kind of figure out a proper path for our actual peer connections to be able to connect with one another. And in fact, these are the ones that are responsible for actually generating these ICE candidates that are pretty much going to be getting sent from one peer to the other peer so that they can come up with some sort of agreement of what they can actually use as a proper connection method to start streaming data between each other back and forth without the actual use of a server. Then finally, what we're doing is we're pretty much attaching 3 event handlers on this peer object. The first one is going to be on ICE candidate. So whenever the browser decides that it wants to go ahead and send another ICE candidate, it's going to go ahead and raise this event, in which case where it's going to go ahead and call our function. So we're pretty much going to have a function called handle ICE candidate event. Then we're going to have another event called on track. This basically will represent whenever we are receiving the remote peer. So in other words, we're finally have a proper connection with another peer, and we have a video chat application happening. So now the remote peer is sending us their stream. So we want to be able to actually grab that stream and display it on screen. That's going to happen inside its handle track event function. So in other words, when we're actually receiving a remote stream, the on track event will fire. It'll then call our handle track event. And like I said, this is where we can actually go ahead and grab that stream and then attach it to the partner video ref, which we have already defined. So as you can see here in our JSX, we have the partner video right over here, right? This is going to be the video tag. So that's where this is going to get populated. And then finally, the last event that we're going to be listening out for is going to be on negotiation needed. So this pretty much is going to define whenever we are starting the sort of negotiation process. Pretty much when a person or when the first person is going to go ahead and initiate that call, the on negotiation event needed is going to, or the on negotiation needed event is going to kind of get fired. This is where the offer will kind of get created and then it gets sent out to the other user. And then the other user will then get that offer, create an answer, and then kind of send it back. This is going to be happening inside of the handle negotiation event needed function. And then finally, the last thing we're doing is we're pretty much just to go ahead and return this pair, which we're then going to go ahead and attach to this pair ref that we've created up over here. Okay, so we've seen here that we have this on negotiation needed event, which is going to go ahead and call the handle negotiation event. So now let's actually go and see what this function does in fact look like. So here you can see we've pretty much defined the function handle negotiation needed event. This is going to accept the user ID as an argument. And then what we're going to do is we're going to take our ref and we're going to go ahead and call the create offer method. So the create offer method will pretty much return a promise. It's going to go ahead and resolve with this sort of offer object. And then we're going to go ahead and call the set local description function. So our own peer is going to have a method on called set local description. So pretty much we're sort of taking this offer and we're setting our own local description. Now again, what this is in fact doing, I'm going to leave the documentation to read up in it a little bit more, but the basic idea is for every single sort of offer and answer, each peer will pretty much have the ability to take an offer to set it as its own local description. And then this then will, when it gets sent out to the other user will pretty much set it as their remote description. So whatever offer you're receiving from somebody else, you're going to set as your remote description. Whatever offer / answer you're creating yourself, you're going to set as your own local description. And then finally, what we're doing is once that's resolved, we're going to go ahead and call the .then. We're going to go ahead and create this payload object. We're going to go ahead and include the target of the person who we're trying to send our offer to. We're going to send their own ID as well by pulling it out of the socket ref.id. That's going to represent the caller, who is the one who's actually calling you. And then the SDP, this actually represents the actual offer data, which we're then going to go ahead and call socket.ref.current.emit. We're going to go ahead and call the offer event, passing in this actual payload, which once again includes who we are, as well as what our actual offer entails. And then should any of that fail, we're going to pretty much come to our .cache and just simply do a console log. Okay, so now we've pretty much seen what it takes to actually go ahead and make the call. Let's now go ahead and handle what happens when actually we're receiving a call. So as you can see here, we already have this. We have socket.ref.current.onOffer. That's going to go ahead and call the handle receive call function. So let's actually go ahead and fill in that particular function of what happens when you are in fact receiving a call. Okay, so here you can see we have the handle receive call function. It's accepting this incoming payload as an argument. And then the first thing we're doing is once again, we're going to go ahead and say peer_ref.current. We're going to go ahead and call the create peer function for the sort of receiving peer. So in other words, now we are not the initiator. We're now the ones who are receiving the call. So we're just going to go ahead and call create peer without passing the user ID, because obviously we're not the ones that are initiating the call. So we're not sending out an offer to anybody. So there's no need to pass in the user ID. We're then going to go ahead and create this description object here by passing the incoming.SDP. So once again, remember the SDP represents our actual offer data. So we're going to go ahead and call the RTC session description constructor passing in this SDP object, the one that we've got as the offer, then this is what's going to go ahead and create the sort of remote description. And so as you can see here, we're pretty much then going to go ahead and say pref.current.set remote description. So remember, as I said, whenever you have an offer, the offer that's local to you, you then set as a set local description or the answer. And then whatever you're receiving from the sort of remote peer, you then set as a remote description. So in this case, this description here represents the description that we have created from the incoming SDP, effectively the remote offer, which is why we're going to go ahead and say set remote description passing in this description object. When this particular promise resolves, what we're then going to do is we're once again going to reference back to our stream, and we're going to go ahead and do the same thing. We're just going to go ahead and get the tracks. We're going to for each over the tracks and then just attach our tracks to our peer. So remember, in this case, we're now actually not the caller. We are now actually the ones who are receiving the call. So in this case, we have to actually also go ahead to our stream, take our stream and attach it to our peer so that our peer can actually go ahead and take our stream and send it back to the person who we're trying to have a chat with. Then finally, we're going to go ahead and create the answer. So we're going to go ahead and say pref.current.create answer. This will then resolve with the promise that's going to resolve with the actual answer object. So the answer object is actually very, very similar to the actual offer object, but instead of it actually being an offer, it's just going to be an answer, but it's pretty much also going to be some sort of SDP data. And then what we're going to do is we're pretty much going to set it as our own local description. And then when that promise resolves, we're pretty much once again going to be building up this sort of payload object where we're going to kind of send the data back to the caller. We're going to tell them who we are. And then we're also going to go ahead and send them along our SDP, which is pretty much is going to represent our actual answer. And then here we're just pretty much calling soccerref.current.emit answer. Go ahead and actually emit the answer event, passing along this payload that we've just created right over here with our actual answer. So now that we've actually gone ahead and answered back to the person who's calling us, now let's go back to the person who's actually made the call and handle what happens when you are in fact receiving an answer from the person who you have called. As you can see here, we actually do have an event that says soccerref.current.onAnswer. When you're actually receiving an answer, we're going to go ahead and call the handle answer function. So let's go ahead and populate the handle answer function right now. Okay, so as you can see here, we now have a function called handle answer, which will pretty much just accept this message. This is pretty much the message that represents the sort of data that we're getting back from the person who we called. And as you can see, we're once again calling the RTC session description constructor, passing in the message.SDP. In this case, the message.SDP will not be an offer, rather it's going to be an answer. But nonetheless, we're still using it to kind of create this description object, which we're then going to pretty much just pass to our set remote description function on our own peer. And this pretty much completes the sort of handshake cycle, right? Because we pretty much have sent an offer out to the person who we're trying to have a phone call with. They have then pretty much taken that answer. They set it as their remote description. They have now in turn created their answer, which they have then set as their local description, and then also sent it back to us. And then we then take their answer and then set it as our remote description. And so we now pretty much have a actual peer-to-peer connection. We've actually got a successful handshake happening between the different peers. But the one thing that we still not actually handled is the actual sending of the actual ICE candidates. So let's go ahead and do that now. Okay, so if we come back to our create peer function, you'll notice once again that we have this on ICE candidate event, which is pretty much calling the handle ICE candidate event function. So this is the function that we've pretty much just defined over here, and it receives this E that is pretty much going to stand for the event. And then what we're going to do very simply is we're going to go ahead and check to see if this E does in fact still have a candidate. Because of course, once it runs out of candidates, it's not actually going to have any more candidates. And then what happens is we're pretty much going to go ahead and create this payload object that includes a target of who we're trying to send it to. And this is pretty much where we're going to be using that other user ref, because again, every person, both ends of the peers, in other words, both peers, both user A and user B are both going to be sending candidates to each other. So they each have their own other user ref that represents the other person who they're in a chat with. So in this case, a target can either be user A if it's user B who's currently sending a candidate, or it can be user B in the event when user A is the one that's currently sending the candidate. And then finally, the other key on this payload object is in fact going to be the actual candidate, which pretty much we're just going to read out of e.candidate. Then finally, we're going to go ahead and send off the event to the server, which we're calling ICE.IceCandidate, passing in the actual payload object. So this now will go ahead and call the IceCandidate event here, which we're listening out for inside of our use effect. And as you can see, it's calling the handle IceCandidate message function. So let's go ahead and define that function now. All right, so here we actually see we have the handle IceCandidate message function. It's receiving this incoming object as an argument. All we're really doing is we're pretty much just creating this candidate by calling the RTC IceCandidate constructor, passing this entire incoming object, because it's going to simply include the actual candidate. And then what we're very simply going to do is take this newly created candidate and then just go ahead and call the add IceCandidate method on our peer, and then pretty much just pass this candidate object in. If it fails, we're just going to go ahead and call the .catch. Otherwise, we're pretty much going to do nothing. And then these peers are just pretty much going to be swapping candidates back and forth until they can actually agree upon an actual method that's going to work for them for a proper handshake. And that pretty much deals with all the sort of round tripping of back and forth of actual data that's going to get sent back and forth between the different peers to kind of facilitate that handshake. The only thing that's left for us to do right now within the actual room file is actually handle the actual logic of actually receiving the other user's stream to then attach it to the partner video ref, which I'm going to show you right now. So if you remember, we actually had in our create peer function, we had this peer.onTrack event, which calls the handle track event. So that's the function that we're going to be defining right now. And the handle track event function will pretty much just receive this E, which is pretty much going to represent the event. And all we're going to do is we're going to reference our partner video ref. Once again, we're going to reference the source object, and we're just going to read the streams of 0. That's just pretty much going to take the stream that represents the actual user's video and audio that they're sending to us remotely through their WebRTC peer. We're going to go ahead and attach it to the source object, and then that's going to get played inside of this video tag. So we have the one video tag to see our own video, and then we have the other video tag to see our partner's video. So that concludes all the actual WebRTC logic that we have here within inside of the room file. The only thing left for us to do now is to kind of go back to the app.js file and actually just do some basic boilerplate of kind of setting up the actual routes of the actual localhost 3000 going to the create room file, and then the localhost 3000/room/room ID going to the actual room file. So let's do that now. Okay, so all we've done pretty much right now is we've pretty much just gone ahead and imported React. We're importing browser router route and switch from React router DOM. We're importing our two files, create room as well as room, from the /routes create room and room respectively. And then finally, we're pretty much just keeping the same app component as the sort of top of a component. We're returning this div that's going to surround our browser router component, which is going to have the switch within it. And then we're pretty much just going to go ahead and define the two routes. The first route is just going to go to /, which will just be the sort of root URL that's going to render the create room component. Then if you're going to go to /room/room ID, that's how you kind of define parameters with React router DOM. That's going to go ahead and actually render the room component. And so that pretty much does it for all these sort of code. There's only one thing that we still need to do before we can actually go ahead and run this application and see if our code actually works. And so for that, we pretty much just need to go to the package.json of the client folder. And all we're going to do now is just basically set up a proxy. So what we're going to do is we're going to just come right over here. We're going to say proxy. And then we're going to go to http://localhost port 8000, right? So that all I've really done right now is I'm telling Create React App, or Webpack Dev Server more specifically, that any request that the client-side application is trying to send off to the server should basically be routed from port 3000 off to port 8000. Because again, the React application in development mode will be running on port 3000. Our server is going to be running on port 8000. So we pretty much want Webpack Dev Server to take any request that the client-side application is trying to make and then simply proxy it off to our server. And so once that's done, the next thing for us to do is to pretty much come back to our terminal. So let's make sure we have both the server-side terminal as well as the client-side terminals open. In the server-side terminal, we're going to go ahead and say node server.js. And then in the client-side terminal, while the actual backend server is already running, we're going to go ahead and run the command yarn start. So both of these have to actually happen at the same time. Okay, so now that the actual application is running, we're going to head on over to localhost 3000. And as you can see, we're met with a page that has a simple button that says create room. We're going to go ahead and actually press create room. You'll see that the browser is now asking me to grant it access to my microphone as well as my camera. I'm going to hit allow. This will now show me my own video, as you can see here. I'll then grab this URL, copy it, open up a new tab, paste it, and if it all goes well, we should in fact have a video chat application. So as you can see, we've got the two video tags. One represents myself, and the other one represents the person who I'm talking with, of course. In this case is myself. Again, I'm sorry, there's a whole lot of me happening. I apologize. But we did in fact build an actual WebRTC video chat application from scratch. Well, that does it for this video. I hope you enjoyed it. I hope you found it useful. If you did, please drop a like, subscribe, and I'll be back next week with another video.
Perfect.